I dropped a bit of a hint in my previous clip that we can get very different behavior just by changing our parametric equation in slight ways. So here was a parameterization of my curve, and I can animate it and watch it trace a curve out of the plane like so. And if I change the formula, I get a very different shape. So again, let me start at t equals 0, and I can trace out where my moving point visits on the plane. And I get a very different picture, although still a curve. This, again, is a curve that I would not want to break up into smaller pieces to do my calculus on. But instead, I know that I don't have to. I already have a formula that governs this curve. The formula that describes this curve is that x equals the cosine of 5 times t, and that y equals the sine of 2 times t. So we get some very interesting shapes in this way. And if you change the formula slightly, we'll get another slightly different shape. We'll get some very symmetric looking patterns when I have, say, integers multiplied on my t's. If I have fractions instead, then I'm going to get different looking shapes. Let me have this go out a little bit further than 2 times pi. Let's go out to something higher. So here is another curve that I've got from graphing a parametric equation. Or I could use an irrational number instead of a fraction. What would that look like? Well, let's see it to start with. We're moving all around. And the further out we go, this parametric equation starts to fill up all of the space inside this square. So again, Desmos struggles with this a little bit. But it's interesting to see we have different behaviors for these very similar parametric equations. And ultimately, the difference comes down to the kinds of numbers involved. I find this fascinating that we can get such different pictures from similar formulas, just with slightly different numbers. It's the numbers themselves that control the behavior that I see. So I know that pi is a number that's close to 22/7. If I did this for a multiplier of 22/7 here, I'd get a picture that looks kind of like this, where again, I get this sort of wave, but eventually it just lines up with itself, and the rest of the graph will continue to trace out the places where it's already been. But if I use a different number here, if I actually use pi, does the function line up with itself? Well, it looks similar. But if I zoom in here, it's not lining up correctly with itself. Let me go a little bit farther out. So if my value of a can keep going, well, it doesn't cover up the place that it's been before. It traces out somewhere new again, right? It's supposed to hit this line here, but it doesn't. So I get very different behavior for this kind of figure if I'm using pi, which is irrational, or a rational number close to pi.